and similarities. Enlargement is the maximization or minimization of an object to obtain an image. Right, so when we talk about the similarities is, when we say something is similar, we're trying to say that probably if it is an object, then that object being similar to another object means that they are the same, right? Objects that are of the same kind could be classified as being what? Similar. Now, under the enlargement and similarities, if our shape is being transformed, say that the shape becomes bigger or smaller, then the one which was transformed to become either the bigger or the smaller is called the object. And then the new figure that is obtained after the transformation, that is what we call the image, right? Now, the term enlargement doesn't really mean that all the time the object is going to be, as the term goes, enlarged, meaning bigger. No, doesn't really mean that all the time image is going to be bigger, right? The image could also be reduced in size, right? Okay. Now, one thing we got to note is that under the enlargement and similarities, if my object is being transformed to the image, and the object that I have is a triangle, if it undergoes the enlargement, the image doesn't become a rectangle, triangle, parallelogram, trapezium. It doesn't become any other shape, but the shape that I transformed initially, right? So that is to say that if I transform a triangle as my object, then my image is going to be what? A triangle. If my object that I'm transforming is a rectangle, then my image is going to be what? A rectangle. If my object undergoing the transformation is a trapezium, then my image is going to be what? A trapezium. Good. Now let us look at this shape here. Now the figure that we have over here is, is comprising of triangles, right? Now we have PQR being transformed to P prime, Q prime, and R prime. Now one thing that we also have to take note is that under the enlargement and similarities, mostly the transformed figure is represented with primes, okay? So the primes that we have here indicate image, and then the PQR indicates the what? The object. So looking at this, diagram that we have here, the O, P, Q, R, any triangle that we take from this is going to be considered what? As the object. Now, when we talk about the primes, then we have to be considering the primes as what? The image, okay? Now, this is not always the case, because it could be that in a question, they have stated clearly that probably the primes gives you your object, right? So you have to read a question to know your objects given, okay? But if nothing of such is stated in the question, then mostly the prime depicts the word, the image. Good. Now considering this shape, O, P, Q, O, this is a triangle, okay? That's a triangle. Now this triangle is an object, and the image of this triangle is O, P prime, Q prime, O. Okay, again we have another triangle here, R, P, Q. Yeah, this is a triangle, R, P, Q, R. It's a triangle, right? But it is an object, and the image of this object is what? R prime, P prime, Q prime, that. So this triangle is an object and the image of it is what? This triangle. Okay. Again, we have another triangle here. O, P, R, O. This triangle is an object. And the image of this triangle is what? O, P prime, R prime, O. Okay, so this will be the image of this object. I believe you can see that. Okay, so having, going through the object and the image that we have in this shape, then we have to talk about a concept that is the scalar factor. Scalar factor. And mostly, the symbol that we use to denote the scalar factor is what? K, right? Now, for the scalar factor, we have a formula. We say that the K is equal to length of image all over corresponding length of what? Object. So that's the scale factor. Scale factor is length of image over the corresponding length of what? Object. Now, to find the scale factor given any shape, then it means you have to consider the length of the image of that object, and then we also consider the corresponding length of what? That object. Now, one thing that we have to also note is that the scalar factor is what? A constant. So given a shape, no matter the side that I'm trying to use to, find my scalar factor, I'm going to always get the same scalar factor, right? Good. So that is to say that if I consider this image, O, P prime, Q prime, then this triangle. See this side, P prime and Q prime, correspond to my object O, P, Q, O. My object this side, the PQ. The P prime, Q prime correspond to what? PQ. But you realize that the P prime, Q prime is what? The image. And then this PQ is what? The object. So my image, P prime, Q prime, correspond to this length, okay? The distance from here to here correspond to this side of my object, PQ. PQ. Okay, and when I do this operation, I'm going to get a scalar factor for this diagram. But note, just as I said, the scalar factor is a constant. So whether I use this side and this side to calculate the scalar factor, or probably RQ and R prime, Q prime to calculate the scalar factor, it's always going to be the same. Because of that, I can also say that R prime, the distance, this R prime, Q prime, yeah, this triangle, right, is the image of this triangle. And this side, R prime, Q prime, correspond to RQ in the object, right? We can also say that R prime, Q prime over RQ can also give us what? Scalar factor. Okay, it can also give us a scalar factor. And again, we can also consider this triangle. See, the O, P prime, R prime. As I told you that this triangle is the image of what? This triangle, right? So if I take this side, P prime, R prime, it also corresponds to what? P, R. Okay, right, so we can say that P prime, R prime over P, R will also give me our scalar factor. So this is the formula that we can use to find the scalar factor of this shape. But actually, any corresponding size could help you find the scalar factor. So this side and this side, this is the image this object, and this side will help me find the scalar factor. I can also consider this side and this side, right, of the triangle. I can also consider this side and that side, and they will give me my scalar factor, right? So in our next video, we'll be solving an example involving what we just demonstrated here. Thank you for watching this video. Subscribe to the channel for more research. Bye.